Okay, so let's discuss a little bit about the Arcane Protons, which also represent the oldest rocks in the Indian Peninsular region. This term Archean, so that means the age ranges from about 4 to 2.5 billion years. Now, these rocks are oldest, of course, so that is one important information about the Cratons. Secondly, these rocks are important because they were formed in the history of Earth when the life had yet not evolved. So they give us a lot of information about the pre-life Earth surface as well as the atmosphere, right? So that is the scientific importance of Archean protons. Secondly, a lot of economically important minerals are also found in Archean protons. Minerals like diamond, iron, nickel, copper, all these minerals, they are found in the Archean cratons. The term craton here, some of you may would like to know, the term craton here refers to the oldest and the stable-most part of the continent. Okay, it's a geological term. So what about the rock types of these cratons? So the rock types or the lithology of cratons which are located in Indian Peninsula, they are dominated by igneous rocks, of course. And what types of igneous rocks? They are granites, they are gneisses. Also, we have basic and ultra basic rock complexes. Basic and ultra basic rock complexes means that these rocks, they are rich in magnesium and iron, and they are derived from the mantle of the earth. So the magma was derived from the mantle of the earth rather than the crust. And as that magma solidified, that led to the formation of Archean protons. This particular map here shows the distribution of these Archean protons, which is given by these dark pink colored polygons that you see here. So let's start from the north. This body here is known as the Aravali Craton. We have 4 cratons, Aravali Cratons. This one is the Bundelkhand Craton. This one is the Singhbhum Craton. Then we have Bastar Craton. And then this large body is Dharwar Craton. And again, you can distinguish between West Dharwar and East Dharwar. That is also demarcated by this line here. What is this line? This is nothing but a zone of or a plane of weakness, a shear zone, which you can use to divide them into west and east parts. Besides that, there's also difference in the degree of metamorphism between western and eastern Dharwar Craton. So when the metamorphism of the igneous rock took place, the degree of metamorphism was different between West and East Dharwar Cratons. Okay, so these, I just wanted to show you a general picture of how these rocks would look like. These are not from the Cratons, but the rocks would resemble something like this. So if you see a granite, it would look like this. Gneisses is similar to granite, just that it has developed foliations or the deformations that you see, which is giving us the evidence of the metamorphism here. Then you have eclogite and lemporite. These are the basic rock types which are dominated by mafic and iron minerals and are derived from mantle. Okay, so now we have been saying that these are Archean cratons. So that means these rock types, they must have been dated, right? So what is the technique or what is the method of dating these rock types? We call them as zircon, uranium, lead dating. These are different types of elements which you can extract and date from these rocks. And this graph here, it shows the distribution of ages which have been done on these different rocks. So on y-axis we have billion years, so right from 3.6 to 2.4 billion years. or giga annum it is written here. Both are same, billion and giga annum. And on x-axis we have different cratons. So we have Aravali, Bundelkhand, Singhbhum, Bastar, West Tharavar and East Tharavar. And these colored horizontal bars that you see, they represent different types of granitoids or granites. You all know that granites are igneous rock types, and again you can sub-classify these rocks based on what is the dominance of a particular kind of mineral there. So something could be potassium rich, something could be dominated by A-type granite. You don't need to go into the details, but just that you should know that how the ages have been attained on the Archean craton. And another important type is the TTG series, which is actually nothing but they represent a type of mineral which are tonalite, tronmetite, granodiorite, right? So in short, it is known as TTG series, given in green color. Now, if you look at the distribution of the ages, what do we see? We see that the oldest ages come from Bundelkhand, also Singhbhum, Bastar, not too many ages, but okay, and also then from West Dharwar, right? Whereas if you look at the rocks which have been dated, I mean the number of rocks or the number of ages that we have from various cratons, Aravali, you see, they don't have much of data as yet, maybe in future. And also not too many ages are coming from Bastar, and relatively younger ages are coming from Eastern Dharwar. This is just to give you an idea how the Archean cratons they have been dated. So you are to remember the age range, the names of these cratons, and maybe this TTG series would be important. But you don't need to go into the details of the types of granites and things like that. Okay, so now while all this activity was going on, you know that Indian plate was still drifting towards the Eurasian plate, right? There were still events of magmatism or volcanism happening. That's how you have deposition of these Archean cratons in the first place. So when did this craton become stable? This became stable around 3 billion years ago or 3000 million years ago. And how this stabilization is represented, or how do we know that this became stable? Because there was setting of a large scale granite body over the cratons. So the stabilization of this Archean craton is represented by the granite, large scale granite emplacement. Emplacement means nothing but just setting in of the large granite bodies. And because there was still drifting going on, ultimately this drifting caused a lot of stress within the cratons. And because there was stress, there was development of weak zones. So rift valleys developed, grabens developed, and that led to the formation of basins. Number of basins or space was created. If I say in layman terms, space was created. And because basins were created, there would have been erosion also by streams that they were flowing, or there might have been rainfall. So erosion was also happening, and due to that erosion, a lot of sediment was coming into these basins. And as these sediments they got solidified, we have sequences of sedimentary rocks also within the large craton bodies. We'll discuss this with help of map also a little bit later. So, and if you talk about the dominance of minerals within these sedimentary rocks which were deposited in the basin, they are dominated by iron and silica. So they contain these rocks contain very rich iron deposits as well. Besides all this information of about pre-life Earth atmosphere, pre-life Earth conditions, these rocks they also tell us something about the tectonic regime of the Indian plate, right? So by studying these rock types and the minerals, geologists and petrologists they have inferred that the plate tectonic like regime, that is where we talk about the movement of the lithospheric plates, where you talk about the divergent convergent boundaries, all those mechanisms that started affecting the Indian plate around 2.7 to 2.5 billion years ago. Okay, that is also known as the Neo-Archean period. And before that, Indian plate did not have plate tectonic like regime. So that is also an information that comes from the Archean Protons when you study them. Also, another important fact about the Craton is that most of the Cratons, they are formed over a very long period, about 250 to 850 million years. And how they were formed? Largely by the episodes of TTG magmatism. So volcanic activity, which was dominated by TTG type of magma. And thereafter, the granitoid diversification, where we saw different types of granites in that colored diagram, that happened in relatively younger phase and also shorter period. So between 30 to 100 million years. In about 70 million years, we saw or rather, we infer that there was granitoid diversification. Several types of granitoid were formed. What does this mean? What is the scientific information that we derive? So what if granitoid diversification was happening? This again suggests that there was a lot of crust mantle interaction going on. So diversification of granite, different types of granites, they develop because the crust and the mantle, they are interacting. And how would they interact? Because the plates, they are moving. You have deformed margins, you have a lot of volcanic activity going on, right? So that again suggests that the uh, tectonic regime of Indian plate had become plate tectonic like as we understand today. So this all information is coming from your Archean Cratons. Another assemblage or another geological unit that you would associate with these Cratons are the early Proterozoic mobile belts. What are these? Again, early Proterozoic refers to the geological time scale, right? When you see the term mobile, what do we start thinking? That it is not rigid, right? So you would expect movement there, or features at least which represent there was once a movement there. So early Proterozoic mobile belts, they are nothing but they represent the margins of these cratons. Now, as the Indian plate was drifting towards the Eurasian plate, there was, of course, stress and strain was created, and the margin of these cratons, whether it is Aravalli, Bundelkhand, Singhbhum, Bastar, and Dharwar cratons, the margins of these cratons, they were getting deformed. They got deformed basically. So those deformed rocks, where you see now a lot of planes of weaknesses, you see that rocks are fractured or sheared, they represent the early Proterozoic mobile belts. And we can classify them as major three belts: Eastern Ghat Mobile Belt, Satpura Aravali Mobile Belt, Chota Nagpur Singhbhum Mobile Belt. So the yellow portion that you see here is the Eastern Ghat Mobile Belt, and as you can see, they represent the borders of these Dharwar, Bastar, and also Singhbhum Cratons. Similarly, Satpura Aravali Mobile Belt would surround your Aravali and part of Bundelkhand Craton as well. And Chota Nagpur Singhbhum Mobile Belt would mostly surround the Singhbhum Craton. Okay. So mobile belts, they are nothing but they are the zones which separate the cratons from one another, or they represent the margins or the shear zones which demarcate the boundary of these cratons. If we talk about the lithology or the types of rocks which are there in mobile belts, they're dominated by metamorphic rocks. And you know that the degree of metamorphism can vary, right? So rock types also, they vary from very high to moderate metamorphic types of rocks. And we have volcanic types of rocks. Again, ultra basic and alkaline bodies are there. So they are rich in magnesium and iron minerals as well. Mobile belts, besides of course representing the shear zones and the borders or the boundaries, they are also the locations where early Proterozoic intercontinental rift basins developed. And as the rift basins developed, there was sedimentation in these rift basins, which ultimately solidified to form various sedimentary rocks, mostly types of sandstones. These gravaks and turbidites, they are special types of sandstones, and also quartz eremitites. This is quartzite, like mostly you can remember it as quartzite, and also basic volcanics. And again, the end of this development of these mobile belts is marked by the emplacement of large granite bodies in the Proterozoic era. So this is the kind of summary or kind of the major information that you need to remember about the mobile belt zones.